right, as usual, this is just a run through of exactly what is on your review sheet. In fact, a lot of them I literally did a cut and paste from the document of your review sheet into this. So it's,
Really?
some of the picture quality isn't quite as much as I normally like it to be, but it saved me about an hour of typing things in. So I was like, yeah, I'll cut and paste to save an hour. But let's name things. Now remember, this first part, we've been over this so many times this year, naming parts of things and stuff like that. You know you need to use the right symbol. If you use the wrong symbol, it's wrong. Because certain things are segments and certain things are lines. No, I don't have extra copies of the review. If you lost your copy I gave you yesterday, you are out of luck. Okay? You'll be able to download a copy of this after I publish it online in about an hour. I'll publish it next hour, and you can always download and print out a copy of this, which is exactly the same as the review. So you'll be fine. So anyway, naming the parts of the circle. These questions on the test are like 1 point each, so they are not like the same as solving for something. Each one of these blanks is just like 1 point, where every other problem is like 3 or 4 points. So don't worry about it too much, but you do need to do it. Name the circle. What's its name? Circle O, okay? And we can just say circle O, or we could use the circle symbol and O, but that almost looks like a pair of eyes staring at you, or one of them's blind, and that's weird. So I like to use the word circle, because it looks messed up. Okay? Name a diameter of the circle. What DF?
Line DF.
Nope. Segment DF.
I did put segment DF. I don't know why.
Okay. Segment DF. What's the radius of the circle? There's several different answers here. I just need one. DO. What DO? Segment DO. Okay. You could use also AO or FO. Any of those are acceptable. What's a secant for this circle? Name a secant. Line DE. Okay, a secant has to be a line. Well, for the way we're doing it, secants are going to be lines. It just makes it easier that way. Technically, you could probably have a secant that's not a line, but we're just going to go with line for secant. Chord. Segment DE, yeah. Chord has both endpoints on the circle. The segment with both endpoints on the circle. And a tangent. How about line AB? Not just the point of tangency. That's not what it's asking for here. It's asking for the tangent line. Okay? So it's not just A is the tangent. That is a point of tangency. Line AB would be the tangent line. Okay? So the secant and the tangent are lines. The others are segments. Watch your symbols tomorrow. Is AB tangent to the circle? Now, this goes back to the beginning of the chapter. What did we learn about a tangent line and a radius? They have to form what kind of an angle? A radius and a line and a tangent line are perpendicular at the point of tangency. They form a right angle. So the way we check that here is by checking to see if this is a right triangle or not. And we have to use Pythagorean theorem. We have to be a little bit careful because the way it's set up here, I'm not just going to do 8, 12, and 16. Those aren't the numbers I'm using. What are the numbers I'm using? 12, 16, and how long is that whole side if we call this call that point C? How long is segment CB? 20. Because, see, we'll call this point D here. CD is 12. It's a radius of the circle, just like CA. So this whole side is 20. So yeah, sometimes we have to add pieces together to get what we need. Just like we were doing with the segment stuff at the end of the chapter. Sometimes we got to add pieces together to get the whole thing. And don't forget, I mean, it's this whole thing that we talked about in class. I mean, if I have, you know, one little block of wood that's 8 inches long and another little block of wood that's 10 inches long, and I put them together end to end, I'm not going to get 8 times 10 inches, 80 inches of wood. I'm getting 18 inches. Right? So put the pieces together by adding, not by multiplying. A lot of people are still getting mixed up with that. Now, how do I check it? How do I check to see if that's a right triangle? Pythagorean theorem. I check to see if a squared plus b squared equals c squared, and which side is going to be the long side. Which one has to go by itself? The 20 has to go by itself. So I check 12 squared plus 16 squared compared to 20 squared. This is a review from our right triangle chapter. How we check right triangle. Or is it acute or obtuse? Really, here all I'm concerned about is right or not right. Acute or obtuse doesn't really figure into it. But it will on the final exam coming up in about a month, so kind of a good idea to keep that in the back of your mind. 12 squared is 144. 16 squared is 256. 20 squared is 400. 144 is 256 is 400, which equals 400, which means that is a right triangle. So is this a tangent line? The answer is, of course, yes, it is. Now, if all you write is yes tangent or no not tangent without any work to support that solution, and you happen to guess the right answer, you will get, congratulations, 1 out of the 3 points for having the correct answer. You must have your work to support your answer at all times. Having the correct answer is only a small part of the battle. You got to do the whole thing. So I would need to see this calculation set up and solved. That's the expectation. Find the value of x. Okay. What do we know? Since these are tangents, we know that 2 tangents from a common external point have to be congruent. That's one of our theorems. So, mathematically, what does that mean? What do we set up? What's the equation look like? Well, tell me what you did. Because a lot of you have been through this already, worksheet. What did you set up? Yeah. Yeah. Not too tough. And we just do a little bit of algebra now. And I get x equals 6. Done. Easy. Okay? Don't overthink some of these. They're pretty easy. These next couple problems deal with central angles. And let's just kind of, as a reminder, look at that little chart that we made again. Ooh, that wasn't good. Let's try that again. Okay. This is a chart that was kind of in your notes. And we're just going to kind of make it rough. But if you haven't put this chart in your notes and there's something you haven't memorized from this chart yet, make sure you get it. Okay. If I have a central angle, okay, where's the vertex? Where's the vertex for a central angle? This is not a trick question. Where's the vertex? At the center. Okay, and the measure of the angle equals the measure of the arc. It's not a 1/2. There's no doubling. Nothing gets doubled or halved or anything like that. The measure of the angle is the same as the measure of the arc. That's the way central angles work. So, that being the case, let's look at this situation. Now, the arcs of a circle have to add up to what totally? 360. So I got a 160 here, a 105 right here, a 65 here. So that's 170 and 160 is 330. How many degrees are left here for GH? 30, okay? Now I can very quickly answer my question. Arc, JIH. I strongly recommend when you are doing this on your test to make sure you get the correct measurement. Literally take your pencil or a highlighter or something like that. Bring a highlighter with you to the test. It's always a good idea. And mark what it is you're finding. That helps you focus in on what you're doing, so you get the correct answer. And then it's pretty easy. It's 160 plus 65. That's what I need, so that's going to be 225. That's the measure of arc JIH. How about angle EDG? All right, let's see what I'm finding. I need to find angle EDG. Oh, that should be pretty easy. This arcs are 55 and 35, so that arc totally together is 90, so this angle has to be 90. Not hard. But the biggest mistake people make on these central angles is they get them mixed up with the inscribed and the other angles, and they start dividing by 2 and stuff like that. But again, if I look at this, if I had said this is 90 and I said, okay, the angle's 45, it doesn't even make sense, does it? I mean, it looks like a right angle. It's pretty close. And I certainly wouldn't double it and say it's 180. It's clearly not a straight angle. So a little common sense, a little thought helps you figure that stuff out. All right, arc or angle. So this gets us to our next type of angle, which is the inscribed angle. Where's the vertex for an inscribed angle? The vertex for the inscribed angle, we've got 4 choices: center, in, on, or out. Inscribed angle is, where's the vertex? You have no idea how worried I become when you guys are just sitting there silent. I think you don't know where the vertex for an inscribed angle is, and that would be very, very bad. Who wants to tell me where is the vertex for an inscribed angle? On the circle. Thank you. The vertex must be on the circle, and the relationship is the measure of the angle is 1/2 the measure of the arc, or if you prefer, 2 times the measure of the angle equals the measure of the arc. If you don't like the 1/2 and you want to do a double instead, 2 times the measure of the angle equals the measure of the arc. It's up to you. I don't care which way you think about it. All right? Either method works. So here, I have inscribed angles because the vertices are on the circle. I also have a second theorem going on here. Opposite angles of a inscribed quadrilateral have to add up to 180. But let's look what we're looking for. Here I just want the arc indicated. I want this arc. But I don't have a central angle or anything to give me that arc. And I know there are people, when it comes to the test, who will just look at that and go, oh, 85. Which, again, that angle, no. Okay? We have to take a look and see, what do we have? I have this angle. Well, kind of. Okay? I basically have that angle, which is 85 degrees, which means the arc that it intercepts is this whole arc, which has to be twice as much. 2 times 85 is 170. But I've used up 100 degrees of arc here, so how much arc is left for the M to L? 70. Okay? So that's just a really good example. We've talked a lot about these multiple step problems, where you don't just give the number and go straight to the answer. That was basically 3 steps. Well, maybe more than that. Identify the angle, identify the arc that goes with that angle, find the measure of that arc, do some subtraction. It's 4 steps to get to that answer. So kind of keep that in mind. Some of these problems are going to have a little more work like that. How about here? Again, you're not going to go directly to an equation setup because the angle I'm working with is right here. RSQ is my angle, which intercepts this arc. So I know that this angle is half of this arc, or 2 times this angle equals that arc, however you want to put it. But I don't know what the arc is. How do I figure out what the unknown arc is? Well, the arcs in my circle have to add up to what? 360. I already know 2 of the arcs. This arc is 65. This arc is 123. So if I put that together, that's 188 degrees used up. So how many are left? 172 degrees left. Which must be this arc is 172. Okay? What's half of 172? 86. So 7x minus 5 is 1/2 of 172, or 7x minus 5 equals 86. Add 5 to each side. I get 7x equals 91. So x equals, what is that, 13? Okay. So again, multiple steps. We use the information to find information we needed so I could then set up and solve a problem. But I couldn't set up and solve a problem based on just the numbers I was given. I got to do some problem solving to get there. All right, now we got our final 2 types of angles. Let's go back here. We have the interior angle. Interior angle. Where is the vertex going to be? Sorry, this is a terrible line. They're not even close to straight lines, but I can fix it, I suppose. There we go. There, better. Okay, where's the vertex going to be for an interior angle? This should not be difficult to figure out. Interior is inside, but not at the center. And with these last 2, we always get 2 arcs and at least 1 angle. So there are several different ways we can think about this. And I can think the measure of angle 1 plus the measure of angle 2 equals arc 1 plus arc 2. Or the measure of the angle is 1/2 the sum of the arcs. Or 2 times the measure of the angle is the sum of the arcs, however you want to put it. Okay? And for the exterior angle, where's that vertex? Outside. Okay? And the measure of the angle equals 1/2 the difference of the big arc minus the small arc, B minus S, I'm going to say. Big minus small. Okay? And yes, you do have to have those formulas memorized. Absolutely, you need to have them memorized and know which one to use when. They're not that difficult. These 2 are very similar, just a plus or a minus difference. Okay, but you have to know which one to use when and then be able to use it. So let's take a look. This clearly is an exterior angle. Okay, and this is a very straightforward problem. This test has an intentional mix of problems that are very straightforward, where you just plug the numbers in the formula and go, and other problems that require you to do a little figuring ahead of time before you can use the formula. That's intentional. All right. Unlike some of the other tests, this is one that, we share tests and we create tests and stuff like that. I actually did the work to create this one. So I know exactly the thought that went into every problem that was selected. So this one is set up intentionally to be very straightforward. If you know the formula and you plug the numbers in, there's very little work to do here. Exterior angle, so the measure of the angle, we'll call that x, is 1/2 the big arc minus the small arc. Well, 176 minus 56 is 120, and half of 120 is 60. Very straightforward. Okay. Number 14. Hey, that's an interior angle. And for an interior angle, what do I know? I know the measure of the angle is half the sum of the arcs. Or, because these two are vertical angles, a lot of people don't like the half here, so they do it that way. The vertical angles, they have to be the same, right? We learned that a long time ago. So the sum of the angles is the sum of the arcs. So 2x equals 160, so x is 80. Okay? So, very straightforward. Then we get problems similar to that, but that require a little more work. So now we step it up just a little bit, don't we? Still just using the formulas, though, because there's a little more algebra involved. 15, again, we're dealing with an interior angle situation. So, arc 1 plus arc 2 equals the angle times 2, or 2 times 2x plus 60. Or 2x plus 60 times 2x plus 60, same thing. So I have to combine terms. That's 2x plus 120 equals 4x plus 120. Subtract 2x from each side, subtract 120. Subtract 2x, subtract 120. I get 2x equals 0. Uh-oh, so that means x equals 0. That's okay. 0 is a perfectly good number. This is an exterior. Just follow your formula. This looks complicated, but it's really not so bad. What's the formula for exterior? Big arc minus small arc. Then what? Does that just equal my angle? No, I got to do big arc minus small arc divided by 2 equals my angle. So big arc minus small arc equals the angle. Now, algebra reminder. When I'm subtracting a sum like this, I have to distribute that negative sign. So that's 150 minus 5x minus 3 equals 46. So 147 minus 5x equals 46. Subtract the 147. Okay, so negative 5x equals negative 101. So x equals 20.2. Is that what it said? Check that answer back. I'm feeling unsure about that. What it's?
Well, that could be right. That'd be a whole number.
No, it's 11. It's 11.
What did I?
Forgot to divide by.
Oh, I forgot to divide by 2. Oh. I knew something was wrong. That answer didn't make sense to me. Big arc minus small arc divided by 2. So 150 minus 5x minus 3. I got to double both sides here to get rid of that. 92. Okay, so 147 minus 5x equals 92. So negative 5x equals negative 55. There we go. X equals 11. Much better. Makes a big difference if you forget to divide by 2, isn't it? Find the error. Always a great way to learn how to do something. That's why I give you those problems in the book too. All right, now we're into the segment lengths. Okay? Here, we multiply two segments equals the product of the other two segments, but sometimes you have to add pieces to get the numbers that we're going to multiply. I pretty much can guarantee you that there's about 3 or 4 people in here, and if I put this problem in test, do 7 times 11 equals 6 times x and try to solve it out. We never, ever, ever, ever use just a chord like that. Okay? When it's exterior like that, it's always point of intersection to point on circle, 7 times point of intersection to the other point on the circle. How long is that blue piece going to be? 18. Equals 6 times point of intersection to point on circle is 6 plus x. There's my equation. Do not be afraid to draw on your picture so you understand and see what you're doing. 7 times 18 is 70 plus 56 is 126 equals 36 plus 6x. Subtract 36. This is nice because it's not quadratic. I get 90 equals 6x, so x is 15. Very similar on number 18. 7 times what? 7 plus x equals 8 times what? 21. 8 plus 13. So 49 plus 7x equals 168. Subtract the 49. I get 7x equals 119, or x equals 17. Let's set this one up. Someone tell me the equation for this one. 6 times what? 6 times what? 6 times 6 or 6 squared, I think I heard. 6 times 6 equals x times 5 plus x or x plus 5. The whole thing. Now this one's going to give me a quadratic, isn't it? Now, if you can at least give me that part of it on the test and show that set up correctly, you've probably got half credit already because you set it up correctly. I don't want too many of your points coming from can you solve the algebra. So if you can show me you know the geometry portion of this by setting it up correctly, you're going to get half credit already for that. Okay? Well, let's do this algebra. In order to solve this, I got to move everything to one side. So x squared plus 5x minus 36 equals 0. And I do my product sum rule. Blank plus blank equals 5. And blank times blank equals negative 36. What two numbers do that for me? Let's think of the factors of 36. If you're stuck, think of the factors of 36. That's 36 times 1, right? That's not going to give me a 5. 18 times 2 is not going to give me a 5. 3 times 12, yeah. And 4 and 9, okay. I was almost there. So it was 3 to 12, 3 and 12. 4 was my next one, right? So it's got to be negative 4 and 9, negative 4 and 9. So this factors into x minus 4 times x plus 9 equals 0. But that's not my solution yet. Those are my factors. My solution is what values of x make these individual factors zeros. So that means x equals 4 or x equals negative 9. We're still not done. Those are possible solutions. I have to make sure my solutions work. Does negative 9 make any sense in terms of this problem? No, it doesn't, because that would give me a negative length. So x equals 4 is my only solution. We call that negative 9 an extraneous solution. That's the word. It means it's extra solution. That doesn't actually give me anything of value. Okay. We got a little multiple choice action going here for one problem. I thought we'd throw a little multiple choice at you, just because, hey, why not? Most of the final exam is multiple choice. It's good to practice it once in a while. And it saves having to write out a big old equation. But please recognize this as multiple choice. Don't think you got 4 different problems here to solve. It's multiple choice. Every once in a while I throw this on and we're not used to multiple choice and someone thinks it's 4 different problems they have to try to solve and they get really thrown off by it. So be careful. Center 6, negative 5. The radius is 2. It's a great practice for your test coming up on Thursday and Friday too. When you're faced with a multiple choice question, eliminate any obviously wrong answer. Is there any answer there that is different from all the others and obviously wrong? B is different. How is B different? It ends with a 1 instead of a 4. Now, does that make sense? Okay, it doesn't, because the radius is 2 and that has to be radius squared. So I know that B is incorrect. Okay, now, the other things I'm looking at, I've got a 6 and a 5, a 6 and a 5, and a 4 and a 3. Is there any other one that looks like it's obviously incorrect? C, the 4 and the 3. Those have nothing to do with it. The only question is it x minus 6 and y plus 5 or x minus 5 and y minus 6? Which one is it? A. A is my correct solution because the x goes to the 6 and the y goes to the 5. It's pretty obvious, and they're always opposite. Okay, this isn't even in the right order. The x and y aren't right. So if you can't immediately identify the correct choice, eliminate obviously incorrect choices. And it's a great strategy in multiple choice, which, like I said, you're going to face that quite a bit again on Thursday and Friday when you're taking your Aspire testing, especially in math. Remember, one of the primary methods you can use on a multiple choice test is to look at the solutions, and especially if it's like a solve for x thing, and plug in the different ones and see if one of them works, instead of having to go through the whole equation solving bit. I mean, if you got a problem like this in multiple choice, and it says find the value of x, that works, and you knew your equation, but you didn't want to have to do all the factoring and stuff like that, well, if your choices were like 4, 5, 6, or 7, I could say, okay, 6 times 6 is 4 times 9. Oh, yeah, 4 works. Doesn't it? And I don't need to do all the algebra portion of it if I can just pick the right solution. Finally, identify the center and the radius of the circle. So the way we do that is write center. Center is always coordinates, so it needs parentheses. Okay, because coordinates always need parentheses. Where's the center for this? X equals 16. Y equals positive 11 halves, because it's always the opposite sign. Radius is what? Radius is the square root of 9, which is 3, because it's r squared in my equation, right? It's x minus h squared plus y minus k squared equals r squared. Like a squared plus b squared equals c squared, Pythagorean theorem. Everything's squared. All right. Anything else you want me to go over further? Now remember, this review, the test tomorrow is going to look just like this review, just different numbers, slightly different pictures. So if you need to watch this podcast again, do so. I'm going to upload it to YouTube right after this class is over. I'm going to uptake these notes. I'm going to upload them to Schoology as well, so you have a completely solved version of the review packet available to you. Lots of good stuff to study tonight. All right? All right. Study hard.